Okay, in 510 we're learning about improper integrals, which are integrals that look like they could be infinite, but we have to check very carefully to see whether they are or are not. In example 1 of your book, or what the book calls type 1, you see integrals like the area up here where you're going off to infinity, and that could clearly be maybe infinite. What I'm about to show you is the other type, the type that might be infinite going up near an asymptote. We handle it the same way. In both cases you identify what the problem is. In type 1 the problem is the region going to infinity, and in type 2 the problem is the region going to the asymptote. So if I looked at this integral, 1 over the 4th root of x minus 3, from 3 to 6, you're looking at this left bit with the slashes going this way. So in order to fix the issue, the possible issue in the domain, to make something that's well defined and proper, we want to get rid of the 3. So the first step we should write is that this equals the limit as a approaches 3 from the right. Now the direction matters because there's 2 ways to approach a 3. Of the integral from a to 6, I'm going to rewrite it as x minus 3 to the negative 1/4 dx. Now I'm going to walk through with substitution just because that's the easier way to see what's going on here. So if I let u equal x minus 3, then du is dx, which makes the substitution fairly simple. You could change your limits, the a and the 6, but since I've got a is already a letter that's standing for something that's changing, I don't want to mess with it. So I'm going to change my problem back to x's at the end. So this is equal to the limit as a approaches 3 from the right of the integral from a to 6, and those are both x values, of u to the negative 1/4 du. Now when I integrate, I'm just going to get the power rule. Notice the word limit sticks around every time. If you leave it off in the middle, you're changing things. So the limit as a approaches 3 from the right of u to the negative 1/4 plus 1 is 3/4 over 3/4. Which is the same as the, from a to 6, which is equal to the limit as a approaches 3 from the right of 4/3 u to the 3/4 from a to 6. So now I need to change it back to x's because I'm taking the limit as x is equal to a approaches 3. So this is equal to the limit as a approaches 3 from the right of 4 x minus 3's to the 3/4 over 3 from a to 6. Now if you look back at our original integral, we probably could have just done this directly if we noticed that the derivative of x minus 3 is dx. Nothing weird would happen. You take your x minus 3 to the negative 1/4 and it gets the new power 3/4, and you divide by 3/4. So those that see that, yes, that is a way to do it. For those that are stuck, substitution can help. Now we plug in our limits. And by limits, I mean the bounds of integration. It's weird that we use it 2 different ways, but that's pretty common. So we've got our 4 times 6 minus 3 to the 3/4 over 3 minus the 4 times a minus 3 to the 3/4 over 3. When you simplify the left term, you get an ugly number, but it is an exact number, so we don't need to rewrite that. So I'm going to simplify in one, so the left side is 4 times 6 minus 3 is 3 to the 3/4 over 3, which I could simplify and make it just a 3 to the 1/4 in the denominator, but that's not the relevant part. The relevant part is we have minus the limit as a approaches 3 from the right of 4a minus 3 to the 3/4 over 3. Now as a gets close to 3 from the right, a is bigger than 3, so a minus 3 is always a positive number, so this makes sense. We're not taking the 4th root of a negative, so it makes sense, and as a approaches 3, this approaches 3. The 4th root is continuous from the right side at 0. So this works. So we can go ahead and just say that that goes to 0. So since that goes to 0, we're left with our 4 times 3 to the 3/4 over 3, which we can simplify as 4 over the 4th root of 3. But both answers would be completely fine. So looking back, we took our possibly infinite piece caused by an asymptote because this 3 can't plug in here. We replace it with a limit. We keep the word limit all the way until we finally get rid of our a at the very end, and we get our final answer. I hope that helps.